Okay, hi guys. So today we're going to do a video demonstration on our group project, which is for ENG20009. So today our demonstration would include two EduPico boards and then one tachometer as well as one Modbus. So our tachometer would be reflected on our two boards with two different slave IDs. And for board number 1, the slave ID is 10. For board number 2, the slave ID is 11. And in both boards, we have a few functions embedded inside. We have OLED, which shows the data of all of the items there, and then we also have the LED function. We also have a buzzer, so later we can see how everything works together when it is applied in Node-RED. So first things first, we set the number of slots for each of the board. So for example, for board number 1, which is slave ID number 10, we will set it to 20. 20 is the default number for the number of slots. Then for demonstration purposes, we'll have board number 2 be set to 30. So now we'll be looking at the RPM. So if we turn the tachometer on, we can see that the RPM for both boards are actually different. So this one is around here and this is around the other number there. So if you are looking at that, it's because of the different number of slots which affects the calculation for the RPM. Then next, if a user wants to input their ideal RPM value, so this is, for example, like maybe today the boss wants this RPM value to be at 500 to be the ideal RPM for the machine. So they can enter manually 500. Then they can say how far apart, what is the range for a safe difference for the RPM. Let's say now the range is 100, or maybe for machine number 2 the range is 200. Then they can set it manually with this arrow here. After that, if it is exceeding the value, then it will have yellow light based on the range increment. But now since that both of them are in optimal conditions, so they are both green in color. If they are too high or they are too low from the ideal value that is being set, then it will be red colored light. Then another function that is connected to this logic is the buzzer setting. So now we only have one buzzer which is connected to board number 1. If it is in yellow color, the light is yellow color, then you can hear that the buzzer speed is something like this. But then if you change it from not red, you want it to be faster, you can change it from this setting here, then it will go faster and faster. Yeah, this is basically the speed setting for the buzzer. And if you do not want any disturbance, you can also off the buzzer so that the buzzer doesn't make any noise. Yep. So this is basically the buzzer connected to the LED, connected to the OLED, where the OLED displays all of the data.
One thing I would like to add on is the EEPROM function. So in any occasion, if the board is suddenly turned off, user don't have to worry about the value being lost because all the values has been saved to EEPROM, and just by opening it again, you can see the value shown here. So the value being saved into EEPROM include the encoder, which is the number of slot, the user input RPM, user input range, buzzer on off, and also the buzzer speed.
Then this is basically our group project, including our tachometer. So that's all. Thank you.